Sometimes it's easier to integrate something with a complex integrand than it is to integrate something with a simple integrand. This is because when we have a simple function and we differentiate it, it'll typically become more complicated, not less. Let's look at an example. For this first example, we can substitute u equals x cubed plus 1 because we can't integrate what's inside of a radical without first substituting what's on the inside of the radical. So we get du over 3x squared equals dx. When we plug this in, we get x squared times u to the 1/3 power times du over 3x squared, and these x squareds are going to cancel. Now we can integrate the u to the 1/3 just by adding 1 here and then dividing by 4/3, so that's multiplying by 3/4. We can cancel these 3's. We end up with 1/4 times u to the 4/3, and u is x cubed plus 1. Don't forget the plus c. As you can see, that was just one simple substitution and our integration was finished. But if we look at this example, we don't have a squared here or a cubed here or a cubed here, making this integral overall less complicated. However, even if we do the same method, substituting u equals x plus 1, the inside of the integrand, we're going to find that this is kind of difficult. We're going to have the integral of x square root of u du. Now x, as we said, we can just solve this equation for x and we get x equals u minus 1. So we have the integral of u minus 1 times u to the 1/2 du. So we're just going to distribute the integral of u to the 3/2 minus the integral of u to the 1/2 du. So here we're going to plus 1, and then so we're going to multiply by 2/5 by 2/3. We're going to end up with 2/5 times x plus 1 to the 5/2 minus 2/3 times x plus 1 to 3/2 plus c. Overall, this was a little bit more complicated because not only did we have to figure out what to substitute for x, we also had to solve two smaller integrals. So, in essence, sometimes it's better to have a complicated integrand than it is to have a simple one.